Today we're going to learn about the factor theorem and the remainder theorem. So we're going to start with the remainder theorem. The remainder theorem states that if a polynomial f of x is divided by, and this says x minus 1, it needs to say x minus a. So if you can make that change in your notes, it'll make things a lot less confusing. The remainder is the constant f of a, and f of x equals q of x, that was the quotient after you divided, times x minus a, so that's what it was divided by, which makes sense, plus f of a, which is your remainder, where q of x is the polynomial with degree 1 less than the degree of f of x. This sounds really wordy, but we're going to go through what this means. So if f of x equals x to the 6th plus x cubed minus 2, then what is the remainder when f of x is divided by x plus 2? Okay, what the remainder theorem is saying is that f of negative 2 because it's going to be the opposite or the root of x plus 2. So f of negative 2 is equal to the remainder when f of x is divided by x plus 2. Okay, so I'm going to prove this to you. So we're going to start out by finding f of negative 2. So remember that to find f of negative 2, what you do is my x became negative 2. So I'm going to plug in negative 2 for each of my x's, because all of my x's became negative 2. Now, if you're using a calculator, which is fine to use a calculator, make sure that you put all of your negative 2's in parentheses, okay? So, I have negative 2 to the 6th plus negative 2 cubed minus 2. So if you don't put your negative 2 in parentheses, what happens is you're always going to get a negative number, which isn't correct. Okay? Because negative 2 to the 6th is actually positive 64. But negative 2 to the 3rd is negative 8 minus 2. Okay, so positive 64 minus 8 minus 2 is 54. Okay, that's what f of negative 2 is. That's the answer. That's the remainder when f of x is divided by x plus 2. But let me prove this to you, the remainder theorem to you. Okay, if I were to divide x to the 6th plus x cubed minus 2 divided by x plus 2, I could use synthetic division because it's in that form. It's x plus 2. It's just 1x plus or minus some number. So I'm going to do synthetic division here. So I've got my negative 2. And then notice that it goes from 6th degree to 3rd degree to a constant. So I've got 1x to the 6th. There's no x to the 5th. Not to the 4th. There's 1 to the 3rd. None to the 2nd. None to the 1st. And then negative 2. So those are those placeholders there. And I'm going to do synthetic division here. So I drop 1. 1 times negative 2 is negative 2. I'm adding, right? 0 plus negative 2 is negative 2. Negative 2 times negative 2 is 4. I'm adding, I get 4. 4 times negative 2 is negative 8. I'm adding. 1 plus negative 8 is negative 7. Negative 7 times negative 2 is 14. I add. I get 14. 14 times negative 2 is negative 28. I add. I get negative 28. Negative 28 times negative 2 is positive 56. And when I add, I get 54, which is the same thing that I got here. Now, why is the remainder theorem even helpful? Well, you didn't have to do all of that division. And so that is why it's helpful. That's the whole point of it. So you don't have to do all the division. You just find f of negative 2 and you move on. So let's look at another example. So if 4x to the 4th minus 3x squared plus 4, then what is the remainder when f of x is divided by x plus 3? Well, I can find that remainder by finding f of negative 3. So again, you need to make sure that you put that all into the negative 3's into parentheses. So that would be 4 times negative 3 to the 4th minus 3 times, negative 3 squared plus 4. So I took negative 3 and I plugged it in for each of my x's. So negative 3 to the 4th is 81. So this becomes 4 times 81 minus 3 times negative 3 squared is positive 9 plus 4. 4 times 81 is 324 minus 3 times 9 is negative 27 plus 4. So 324 minus 27 plus 4 is 301. So my remainder when 4x to the 4th minus 3x squared plus 4 is divided by x plus 3, my remainder is 301. If f of x equals 2x cubed minus 6x plus k, now we don't know what k is, and the remainder when f of x is divided by x plus 1 is 7, then what is the value of k? So let's think about this. Okay, we're using the remainder theorem. So normally what I would do is I would find f of negative 1, and I would plug it in. I would have 2 times negative 1 cubed minus 6 times negative 1 plus k, right? This isn't going to get me super far. I'm trying to find the value of k. So, and then there's this other information that I didn't use here. It says the remainder when f of x is divided by x plus 1 is 7. That's this. F of negative 1 then must be 7 based on this information, right? Because if I were to divide by x plus 1, then I could plug in negative 1, I would find f of negative 1, and I would find my remainder. Well, they told me that my remainder was 7. So I know that 7 is equal to 2 times negative 1 cubed minus 6 times negative 1 plus k, and now I can solve for k, which is what I'm going to do. So I get 7 equals negative 1 cubed is negative 1. Negative 6 times negative 1 is plus 6 plus k. So this is 7 equals negative 2 plus 6 plus k. Or 7 equals 4 plus k. I subtract my 4, and so k is 3. I could find out, right? I could plug in 3 right here and see what happens. So if I did that, I'd have 2 times negative 1 cubed, which would be 2 times negative 1 or negative 2, minus 6 times negative 1, so plus 6. So I have negative 2 plus 6 is 4, plus 3 is 7, and it said that my remainder should be 7. So I know that that's right. So again, if f of x equals x cubed minus 6x plus k, this is the same idea here. And the remainder, when f of x is divided by x minus 1 is 14, that right there means that f of 1 must be 14, right? Normally I would find out, okay, what is the remainder when f of x is divided by x minus 1? I would find f of 1, and that would tell me what my remainder is. Well, they told me that my remainder is 14. Then what is the value of k? So I'm going to find out. If f of 1 is 14, f of 1 is also equal to 1 cubed minus 6 times 1 plus k. I know that f of 1 is 14. I'm just going to plug it in there. So I have 14 equals 1 cubed is 1, minus 6 times 1 is negative 6, plus k, or 14 equals negative 5 plus k. I add 5. Whew. and 19 is k. So again, if I were to plug that into this part of the equation right here, I'd have 1 cubed, which is 1, minus 6. 1 minus 6 is negative 5, plus 19, that's 14, and I know my answer's right. That's the remainder theorem, factor theorem. So factor theorem is next. When f of k equals 0, then x minus k is a factor of f of x. That's what the factor theorem says. So let's think about this. This is saying that there is no remainder, right? Because f of k would give me what my remainder is, and if my remainder is 0, there's no remainder, then it must be a factor. That's how we get no remainder. It's a factor. So, given f of x equals x cubed minus 12x squared plus 20x plus 96, is x minus 8 a factor? This is asking, is f of 8 equal to 0? That would tell me that it's a factor. So I'm going to find out. Okay? So I've got 8 cubed minus 12 times 8 squared plus 20 times 8 plus 96. It's a lot. All right. 8 cubed. So 8 cubed is 512. Minus 12 times 8 squared is 64. Plus 20 times 8 is 160 plus 96. So I have 512 minus 12 times 64 is 768 plus 160 plus 96. So if I put that all into my calculator, I have 512 minus 768 plus 160 plus 96, and I get 0. That means that, yes, 8 is a factor because I got 0, because my remainder is 0. So let's do this one more time. Is x plus 7 a factor? That means, is f of negative 7 equal to 0? That's what they want to know. Is f of 7 equal to 0? So let's find out. Negative 7 equal to 0. So I've got negative 7 cubed minus 12 times negative 7 squared plus 20 times negative 7 plus 96. Okay. Negative 7 squared is negative 343. Negative 12 times negative 7 is positive 84. 20 times negative 7 is negative 140 plus 96. So I want to know, is negative 343 plus 84 minus 140 plus 96, it gives me negative 303. Because my remainder is not 0, so here's my thought bubble here, right? Not 0, so not a factor. This would be no. Let's look at another one. Oh, not sure what happened there. Let's see here. So, let's say, no, that's it. All right, so you've got homework on Delta Math tonight. If you have any questions, let me know.